less than z less than 70.5 minus 75 divided by 4.33 minus 1.04. Make sure you round to two places because you're about to look up the z table. So minus 1.039 became minus 1.04. And then I will go look these two up. Minus 1.04, and here I have minus 1.27. So we will look up this area and we will look up this area and then subtract. So can you give me the two numbers, the one that goes with minus 1.04 on the z and the one that goes with minus 1.27 on the z? Or just give me your z table and I'll do it. Thank you. So minus 1.04 minus 1.0 and 4 is 0.1492, 0.1492, and then minus 1.27 gives me 0.102. 0.102. So my answer is 0.1492 minus 0.1020. So 2740. 0.0472 is my final answer for this problem. So the error is equal to the absolute value of the approximation minus the exact answer. So I get 0.0472 minus 0.0458. So look, I'm hardly off by anything. 0.047 minus 0.046. That's what this boils down to. So I'm off by 0.001, which is nothing. 1/1000th. Imagine. Right? It's a great approximation. You get it, right? Okay, keep going. We'll just keep playing. Yeah.
So will it always just be 0.5 less than and then greater than?
Yes.
Oh, okay.
Yes, and I'll keep on doing problems. Can you please pass this down? So back to this page. If we wish to say r greater than or equal to 5, would correspond to x greater than or equal to 4.5. Let me draw the picture. Here's 5. I'm still drawing pictures even after 40 years, and I suggest that you do the same because it'll just put it in place for you. So r greater than or equal to 5 means you want this bar for 5 and all bars that come to the right of that, right? So where does this begin? 4.5. So that's why r greater than or equal to 5 translates to x greater than or equal to 4.5, where x is continuous and r is discrete. That's the continuity correction right here. So you better start at the leftmost end of the bar if you're going right, and you would start at the rightmost end of the bar if you were going left. Like this. If we wish to say r less than or equal to 5, then I'd go this way. 4.5, 5.5, and I'm going this way. So if I want to include that bar for 5, then I have to start at 5.5. So probability x less than or equal to 5.5 would be the same as r less than or equal to 5. Follow me? So yes, it's always 0.5, but if you're summing right, you start at the leftmost end of the bar. If you're summing left, you start at the rightmost end of the bar. And this is the same thing I would do if the question was, find the probability that r strictly greater than 4. If that was the question, I would say more than 4 successes is equal to R greater than or equal to 5 is equal to X greater than or equal to 4.5. Does that make sense?
So you're always looking to make the amount of data that you're calculating larger when you add the correction in, pretty much?
Yes.
Okay.
Yeah. So the point I'm trying to make here is that strictly greater than 4 doesn't include 4. So I better start at 5, but then the bar for 5 begins at 4.5 for X. Get it? Similarly for this one, the question might have been find the probability that R less than 6. So this question would say fewer than 6 successes. So then I would have to translate that to R less than 6 is equivalent to R less than or equal to 5. The whole objective is to get it to the place where it's less than or equal to something, so you can talk about that bar where it's less than or equal to or greater than or equal to. So here it was greater than or equal to 5. Here it's less than or equal to 5. Follow me? Okay. Question? Is it making sense? Okay. Page 3, lecture 7. Let's do some problems. That's it. There's nothing new, guys, past this point. You've seen everything that you're going to see. This is page 2. And then we'll switch over to here. N equals 25, P equals 0.3. Find the probability R greater than 11. So first let me do the exact answer. Probability R greater than 11 is equal to probability R greater than or equal to 12. Do you agree with that? Always want to put it in terms of including a certain. Then I go to my bar for 12. Well, I want the exact answer first, so let's see. Greater than or equal to 12. So this is equal to probability of 12 all the way to 25. So I say who's missing? 0 through 11 are missing. So this is 1 minus the probability of 0 through 11. This is old stuff, right? You've seen this before the test. Equals 1 minus binomial CDF NP11. So N is 25, P is 0.3, and 11. Let's do it. Second distribution, binomial CDF of 25, comma 0.3, comma 11, and I want 1 minus that. So I got 0.0442. That's my exact answer. Next, I'm going to do this by normal approximation. So first we have to check to see if NP is greater than 5 and NQ is greater than 5. If it's not, then I cannot do any of this. So N times P, 25 times 0.3 is 7.5. So that one's greater than 5. And 25 times 0.7 is also greater than 5. So both of them are greater than 5. So I can continue. I can stick it in the mailbox because I think I needed to lock the door, don't I?
so, but if you want to keep it, that's fine.
I'll stick it in her mailbox. Would that work?
Sure.
Thank
I'll just
you.
let her know.
Thank
Okay,
you.
You're welcome.
What was I saying? Normal approximation. Yeah, let's draw the bar. So r greater than or equal to 12. So I'm at 12. And I want this. 12 and everything to the right of 12. So probability r greater than or equal to 12 translates to x greater than or equal to 11.5. Then I need a mu and I need a sigma. So mu equals n times p, which is 7.5. And sigma equals rad n times p times q. (25) times 0.3 times 0.7 and the square root of that. 2.2913. 2.29. Almost done. So this is equal to probability z greater than or equal to 11.5 minus the mean divided by sigma. So probability z greater than or equal to 4 divided by 2.29. 1.75. So then I go to my z. I go to 1.75. I'm interested in that area. So can we look up 1.75 on the z table? What do we get? Point 0.9599. So then this part would be 1 minus 0.9599 or 0.0401. That's the answer by approximation. So absolute value of the error is equal to absolute value of 0.0442 minus 0.0401 equals 0.004. Negligible. Get it? Let's do the next one. The probability is 0.65 that an animal survives migration to its winter location. For a random sample of 500 animals, n equals 500, use the normal approximation to the binomial to find the probability that between 310 and 340 survive migration. Probability inclusive, so 310 less than or equal to r less than or equal to 340. So the bar for 310 all the way to the bar for 340. I always draw the bar so that I can think it through. I want all these, all this probability. So looks like it starts at 309.5 and looks like it ends at 340.5. X, right? That's X. So let's write it right here. Probability 309.5 less than or equal to X less than or equal to 340.5. So the top one is discrete. The bottom one is continuous. And now I'll change it to Z.